we're going to do another example here on Camry cars. A used car dealer is about to bid on a 3-year-old Camry equipped with the standard features and with 40,000 miles on the odometer, which is the same as the mileage. He does not know how much to bid. You decide to help him and make an informed decision using regression. So you want to help him so he can make an informed decision. So we need to define the dependent variable y and the independent variable x. We are given the information, and I will make this available to you under Toyota Excel data in your titanium. So we're given a bunch of information. In fact, if I scroll down, we'll see we're actually given the information on 100 cars. So we're told, say for the first car, the price is $14,600 because it's in thousands, and the mileage is 37,400 because it's in thousands as well. So what would you say is the dependent variable? And if you think about it for a little bit, you're probably going to say that price is dependent, and the dependent variable is going to be y. And so price is going to be dependent on the miles. So the more miles it's got, probably the cheaper it's going to be. It's going to be the less expensive it's going to be. So we've got the dependent variable as the price depends on mileage, and so that's the first part of the question answered. Okay, so the first part here would be this guy's the dependent variable is price and the independent variable is mileage. Draw a scatter plot using Excel. Okay, let's go back here. So to do a scatter plot, we have one little problem, which is Excel wants the data to be x first, then y for a scatter plot. So I'm going to have to actually switch these over. So you can just copy this, you can take this data and you can cut it away from there, and you can just paste it up here. The ways you can do it, but there you go. So the reason I just did that is because Excel, I can delete this column as well. Excel does not like to have y first, then x when it's going to give you a scatter plot. So to get a scatter plot, let's highlight all the data. So that's all the data highlighted, and we're going to press Insert, and we're going to come over here to Scatter Plots, and press on Scatter Plot, and that's what we get. So that data's pretty compelling, I'd say, showing me that I've got a negative relationship. So as the mileage increases, the price is decreasing of the car. So they seem to be fairly bunched together. So the very first thing we're doing to actually eyeball the information is suggesting, yeah, we really do have a linear relationship. Fairly strong indication that we do. So that's the second part of the question. So we've done our scatter plot. Using Excel data analysis, find the regression equation. So there's what we can do to do this is we can click on any one of these points, and we could go down to add a trend line, and not only will it add the best fit straight line through that, the points are so closely knit you can hardly see it, but it starts at this point here and goes to that point there. But we could actually display the equation on chart, so it's a bit hidden, so let's move it to here. So that's the regression equation. But it's not the way we're going to actually do it, but it's going to be 17.249 minus 0.0669x, where we know what x and y are. X was the mileage and y is the price of the car. So what we're going to do now is we're going to hit data analysis. We're trying to get the regression equation. Scroll to regression, press OK, and we're going to input our data. So our y range first this is our y range. It's our y range, and our x range. So our x range is going to be this one here. Okay, and so I will click on labels because I did include labels. We can put confidence levels. It's going to default to 95%. We're not actually concerned about that, to be honest with you, for right now. but let's put it in at 95%, because it could well be that the significance level is going to be 5%, or if they don't tell us, we'll take it to be 5%. Output range D1, that's fine, and we're going to get the output all the way up here. So that's the output that we've got. And if you notice that the intercept and the slope are the same values we had down when we did that shortcut using the table. So the equation is going to be y equals the intercept plus the slope, the intercept being 17.2425 say, and the slope is going to be negative 0.067. So let's go over to the Excel. So the actual value we're going to get in here is going to be 17, or we can just do it like that. So y is going to be the price of the car is going to be equal to, I'm rounding these figures and they're in thousands, don't forget that, 17.25 plus, minus 0.067, and x is going to be the mileage of the car. Okay, so that's that part done there. Moving on, based on this regression model, this one above, we also would like to test whether or not there is a relationship between sale price and mileage. Formulate the appropriate hypotheses using correct symbols. So we want to check to see if there's a linear relationship, and if you remember the way we do that, I can draw it out for you if you've forgotten. So what we can do for that is we can actually test the null hypothesis of H0. If you remember what the null hypothesis was for that, the null hypothesis for that is going to be that the slope beta1 equals 0, and the alternative hypothesis H8 is going to be that the slope at the population level, beta1, does not equal 0. Now, if the slope equals 0, what does that mean? If the slope equals 0, just over here, if the slope equals 0, that means there is no linear relationship. So I'll just put no linear relationship exists between the two variables, and otherwise there is a linear relationship. If we reject H, there is a linear relationship. And to test that, the easiest way to test that, remember we're looking at the slope. So this in here refers to the slope. Everything along here refers to the slope. The easiest way to do it is, say, take an alpha value, since we haven't been given one, of 5%, and take a p-value. The p-value is actually given to us, and the p-value is going to be, well, that's a very small number. If you're not sure that that's a small number, just go onto that small number, onto that number, and press the percentage key, and that's going to be 0. You see that? And if you want more decimal places, well, it's 0 to quite a long way. At some point it's going to change from 0, not anytime soon. There was many leading zeros. I think it was e to the whatever it was, many decimals. So you can change the format on that to get that format. Yes, we have to go 24 zeros before we actually get that 5 in there. So that number is a very, very small number. And what it basically means is that e to the minus is basically saying that we have to move 24 spaces. The decimal point has to move 24 spaces in this direction. The minus means that the negative direction before we get to the actual number. So our number is going to be 0.23 or 24 zeros, and then 57 0.00758, so it's a very, very small number. So we can basically say that the p-value here is approximately 0. So that's a p is approximately equal to 0. And what do we know? We know if alpha is greater than or equal to the p-value, we reject H0. And in this case, alpha is greater than or equal to the p-value, so we're going to reject H0. We're going to reject H0. We're going to go with the alternative. So there is a linear relationship. If you wanted, you could have done the hypotheses test to do that. But if you do the hypotheses test, remember it's going to be a two-tailed t-test. I'm not going to do the whole test. It's going to be a two-tailed t-test. Have to work out the critical values. You also have to remember that the degrees of freedom are going to be n minus 2. And you actually are going to be given the test statistic here, but you also have to work out the critical values using the t distribution. So that was that part done. So we've done 4, 5. Find r squared, which is also known as the coefficient of determination. Does it suggest a strong relationship between mileage and price? Let's have a look. Where's r squared? Let's go over here. So r squared is right here. And you can see r squared. It's 0.64, 0.648 or 60, around 60, 0.64, 0.65 is about 65%. So if you remember that r squared lives on a number line between 0 and 100, or 0 and 1, depending if you want to talk about the proportion, 0 to 1 or 0 to 100 as the percentage. So if we go about 0.64, if that's 50%, 64% is over here. So it's not bad at all. I mean, it's giving us indication again that there is a good linear relationship between the two variables. And we also saw that from the graph as well. And we also saw that by running this test as well. So there's 3 tests we've done now to establish whether we've got a nice linear relationship between these two variables. The first one was the graph that we saw that gave indication that we have a linear relationship. Even though it's negative, it's still fairly strong evidence of a linear relationship. We then did this test over here on the slope to show that there's a linear relationship. And then we see r squared. It's closer to 1 than it is to 0. Closer to 1 meaning that we're closer to being perfect than having no linear relationship. So we should be able to use this to predict what's happening in terms of price of cars. So what else have we got to do there? So it does suggest a strong linear relationship. 6. The used car dealer is about to bid on a 3-year-old Toyota Camry equipped with the standard features and with 40,000 miles on the clock. Using the estimated regression model, which is the one that we've got in yellow up here, what would be the predicted sale price of this Camry, as well as the 95% prediction interval? So basically, the predicted sale price, all I have to do is say, okay, they've got a car with 40,000 miles. They want to predict what it's going to go for. This is a future event. They're looking at this just one car, a single car. And they want to predict what it's going to be worth in the auction when it takes place, maybe tomorrow, maybe in an hour. They want to predict how much the car's worth. So all I have to do is put my 40 into here. Not 40,000. I just need to put 40 into here because remember, we're dealing with thousands of miles. So all I have to do is put 40 into here. So we can do that, go back to the spreadsheet, and we can just put, let's go somewhere to put, where should we put it? Let's do it somewhere down here. So the price of the car, if a car has 40,000 miles on it, let's just do it like that, 40, what's the estimated price of the car? All I'm going to do is do the calculation, which is going to be equal to the intercept. And I will put plus the slope, because the slope here is coming out as being negative. And I'm going to multiply that by 40, not 40,000, but 40. So this is the price of the car. The estimated price of that single car, which is 14.57, and that's in thousands as well. So it's $14,574 would be the predicted price of the car. So we're predicting that the price of an individual car is going to be that amount. And they also want a 95% prediction interval. So they're saying, okay, the price of the car is 14,000. You're predicting that the price of the car is going to be $14,574. But that's just a single point, a single value. Can you give me how much that car's likely to go for from the lowest to the highest price for that individual car with 40,000 miles on it? And we can do that in a second to find the prediction interval. If we also look at the next question, it says the used car dealer has an opportunity to bid on a lot of cars offered by a rental company. The rental company has 250, just meaning a lot, of Toyota Camrys, all equipped with standard features. They all have standard features. All the cars in the lot have around 40,000 miles on their clocks, on their odometers. Using the estimated regression model, what would be the 95% confidence interval? So before we asked for the prediction interval, and now we're asked for the confidence interval, the difference is that the prediction interval was looking at the range of prices for an individual car to be sold in the future. The confidence interval is based on the average price of all those cars, and it's the interval based on the average price of all those cars that we've got in here. So that's the difference between the two, and it's the way that they use the data. This prediction is based on one, confidence is based on the average of many. So the reason that I delayed answering this is because we actually have the template, and so if you go over to Titanium, you see there is a regression interval template, and we can use this for calculating prediction and confidence intervals. And all we have to do is open it up and put the data into it. So the data that we're going to need to know to put into it is, we need to put in we need this data, and we need this data, and you just need to put that into the interval. To find the intervals, you just need to put that data in to here. So the easiest way to do it is to cut and paste the data, or you can actually type it in. So what I'm going to do, I'm actually going to type it in to make sure that you're aware of which data I'm actually putting in and where I'm gaining from. Even though I've highlighted it, I want you to see individually where I put that data in. And I'm just going to put that in. The easiest way, as I said, is just to copy and paste it. But let's just do it into this. That's the template. Okay, so let's go into the template. There you go. So this figure is 17.248,727. This figure over here is 0.1820926. So barring any errors that I'm making in inputting this data, this one's going to be negative 0.066 861. This one over here is going to be 0.0049746, and the standard error is going to be 0.3264886. Sample size was 100. X was the price of an individual car, sorry, the miles on an individual car, which was 40,000. We're just going to put 40 into here. And then alpha, let's keep it at 5%. So this is actually giving us the point estimate which we worked out before, which I believe was 14,000 or 14.57. Let's have a look if it's the same figure we had before. Yeah, 14.57. So barring any little mistakes I may have made in copying those figures over, we should be okay. And so we'll get the prediction interval as being 13.92 up to 15.23, and the confidence interval is 14.5 through to 14.65, and of course that's in thousands of dollars. So the prediction interval saying that any individual car, or sorry, for that specific individual car that has 40,000 miles that he was thinking of bidding on, that car is going to be worth, as a point estimate, $14,570 or thereabouts, and a range for the value of that individual car is $13,920 up to $15,230. But when he wants to bid on the one of the group of 250 cars that were in the auction that came in from the rental company, the average price of any of those cars ranges from $14,500 to $14,650. And that's just completed the question.